Okay, this is going to be the first video in several videos about the last quiz. So what I'm going to do is basically talk you through the problems from the quiz. This video is going to cover problems 1 through 4, and you can feel free to pause the video at any time. Basically what I'll do is talk you through the problems, and then what you'll have to do is try a problem similar to the one that you got wrong on the quiz. So the first question that we're going to do is number 1. So we have several swimmers are on a special blank day training program. For quiz A it was 9 and for quiz B it was 12. The amount that they swim in the first day is different, and the percentage they increase by is also different. Now the key to this problem is recognizing that that you are changing by a percentage, which is a hint that this is a geometric sequence or a geometric series. So automatically you should be thinking, okay, as to say, a geometric sequence or a geometric series type question. So the first question is, how far would each swimmer swim on day 5 or day 7 if you're answering the quiz B question. So since I'm asking for a place in the sequence, this is a sequence type question. So really what I want is the explicit form for a geometric sequence. That'll tell me what's the place on day 5, or what's the value at position 5. So what we do is we find the first term, which is g sub 1, so it would be 150 in quiz A and 50 in quiz B. The growth rate, or the R value, is going to be 1 plus 0.15, or 1.15 and 1.18 for quiz B, and then we take it to the n minus 1 power. So now all I have to do is substitute the 5 in for n, and you can see that we get 262.35, or in this case you put the 7 in for n and you get 134.97. So that's the answer to part A. For part B, they're asking for the total distance. So what you're doing is adding up what they swam on day 1 with what they swam on day 2, all the way up till day 9, or in this case in form B, day 12. So this is going to be a finite geometric series. Remember, a geometric series is adding the terms together of a geometric sequence. So all we have to do is identify the same values for g sub 1, for r, and for n, and add and substitute them into the formula for a finite geometric series. That formula is g sub 1 times 1 minus r to the n, all divided by 1 minus r. Remember that you can make some calculator mistakes, so be very careful with how you substitute in. With this problem, I should have put in the 150 here. I did that in the form B. But you can see the answers here. And so, obviously, that's how you would do part B. Now, here's what I'd like you to do. This problem is similar to the problem number 1, so I want you to try that problem. Put a number 1 on your paper, and you can do this problem instead. I'm going to move on to number 2, so if you want to do this problem, you may want to pause the video. Alright, number 2. We wanted to know the sum of the first 921 odd numbers, or the first 627 odd numbers. So if I were to list the odd numbers, I'd have 1, 3, 5, 7, etc., etc., etc. Now, since we're looking for the sum, we're adding those together. If I were just to list them, I would have an arithmetic sequence. But because I'm adding them together, that makes this an arithmetic series. So the first thing I need to do is find out what is the 921st odd number. And the way that I can do that is to find the formula for an arithmetic sequence. Now, I know that sounds confusing, but remember that each term in an arithmetic sequence can be written as following an arithmetic sequence. So I think I said sequence when I meant series. So each term in a series, in an arithmetic series, can be written as following an arithmetic sequence explicit formula. So really what I need to do is use the formula for an arithmetic sequence. to find out what the 921st odd number is, or the 627th odd number. So I start with a sub 1, which is 1, plus n minus 1. So in this case, the 921st term would be n minus 1 times the constant difference, which would be 2. So to find the 921st term, I just substitute that in for n, substitute 1 in for a sub 1, and 2 in for d, and I get 1,841. So now I have the first term and the last term, and now I can evaluate the sum of that arithmetic series by taking n divided by 2 times a sub 1 plus a sub n. First term plus the last term times the number of terms divided by 2. And that's how we get 848,241, or in this case 393,129. There is another formula that you could use for this, and it would actually make it a little bit easier if you use the other formula for finding the value of an arithmetic series. It might make your life a little bit easier because you would essentially find the last term by just substituting in everything that you knew. You wouldn't have to go about finding the last term. You could actually use the other formula, and it would also work. So the problem I'd like you to try is, what is the sum of the first 352 even numbers? So if you're going to try that problem, pause the video at this time. If not, you can just keep watching, and I will go on to number 3 soon. Alright, number 3, we're asked to calculate the sum of the following. So they are both geometric, and the reason that I can see that they are geometric is if it was arithmetic, I'd be adding 3 each time. Well, there's no way that by adding 3 each time I'm going to end up at 153.7734, etc., etc. The same thing down here. The constant difference, if this was arithmetic, would be I'd be adding 1 each time, and there's no way if I'm adding 1 that I'm going to end up at 15.2587. Now, we can use logarithms to find out what term number this value is. But, like I said in class, it might just be easier to guess and check. So that's what I did here. You can use logarithms to try to find that place. But I found that it was the 9th term, basically by figuring out what's the power I'm going to take 1.52 times 6 to get that value. So since it was the 8th power, that tells me that this is going to be the 9th position. So again, you could use logarithms to find out what that is, but it might be easier just to guess and check. It might actually take less time. Obviously, we're getting the 1.5 from taking 9 divided by 6, and 6 is our first term. So once I've identified what G sub 1 is, what R is, and what N is, I can then substitute those into our formula for a finite geometric series. It's finite because we're going from 1 to 9, the first term to the 9th term. Substitute those values in and you get 449.32. The same thing with quiz B. Your R value is 1.25. Again, you can guess and check to figure out that that is the 7th term, and or you could use logarithms and you'll get 60.29 as your answer. So the one I'd like you to try is this one, 5 plus 7 plus ... all the way to 37.64768. Alright, we're going to do number 4, and that's going to be the end of the first video. Okay, so for number 4, we're asked for to the nearest hundredth, what is the value of, and it looks like this is going to be a series. The summation notation, the sigma notation, tells me that this is going to be a series for both of these parts. It's going to be finite because I'm starting at 1 and ending at 25. For this one, I'm starting at 1 and ending at 30. This part right here tells me it's geometric. If I were to list these terms, if I were to list this out, the first term would be 9. If I put 1 in for n, 1.4 to the 0 power times 9, the first term would be 9. Then I would have plus 9 times 1.4 to the 2 minus 1 is first, so I do 9 times 1.4, and I would have the next term. And I could do that for 30 terms, but nobody wants to do that. It would take you a very long time. So what you're going to do is use the formula for the sum of a geometric series. It's a finite geometric series because we're stopping at 30. Here's the formula: g sub 1 times 1 minus r to the n, all divided by 1 minus r. And you can see that we get 544,509 for the form B question, 18,790.43 for the A question. The problem is essentially the same. Now for the second part, again we see that we have a geometric sequence, and we're adding together all of the terms of a geometric sequence, and this time we're going from 1 to infinity. So that tells me that this is an infinite geometric series. The first thing I do is look at the value of r. If r is bigger than 1, then I know that no sum is possible. Think about it. I'd be adding numbers that increasingly get bigger. So the next term will be bigger than the last term. Then the next term will be bigger than the last term. So if I were to add all of those together, no sum would exist. But since this value, this 0.63, is less than 1, that tells me that each successive term in the series is getting smaller and smaller and smaller. So as I go towards infinity, each piece is getting smaller and smaller and smaller. That tells me that I'm going to converge upon an infinite sum. So the formula for the infinite sum is g sub 1 times 1, or excuse me, g sub 1 divided by 1 minus r. So again, all I have to do is identify what these are. G sub 1 is 15. R is going to be the 0.63, substitute everything in, and you get 50.54. Same thing with the Form B question. If you got these wrong, try these two problems on your paper. Alright, that's going to end the first video. We're going to do numbers 5 through 8 in the next video.